Okay, this video is about angles in a angles in a circle at National 5 level. A few wee things you have to know about in terms of properties. Now, this is going to be very, very short. I won't do any examples in this apart from just showing you the types of angles that you're looking for. Probably make up 3 videos in this, maybe 3 or 4 videos, and the next ones will be all examples. So what do you have to know angles in a circle? Well, the first one that we'll come across is triangles. So quite a lot of times you have lots of triangles within a circle, and here's the properties that come out from that. I'm going to draw a diameter in. The diameter, remember, goes through the centre of the circle from one side to the other. Now, if I now make a triangle such that the diameter is the hypotenuse, the longest side, if I take a length from here and a length from here and I get it to meet on the circumference, well, there's a special property here, and I'm just going to show you what it looks like. Okay, so I've got this line. If I just put it down to here and put another one from the other side so they meet the circumference, and you'll see that it looks like a right angle. It turns out that it is a right angle. So if we have a triangle within a circle and the hypotenuse is the diameter of the circle, then you always make a right angle at the circumference where the 2 lines meet. So that's a property you have to be aware of. It comes up an awful lot, so you need to be aware of it. I'll just put another triangle in here and we'll show you another one. So here's the diameter. So that's the diameter of the circle. So if I form another triangle on the circumference, on that side and on that side, there we go, then this is a right angle, because this triangle here, you can see that that's the diameter and that's the hypotenuse of this triangle here. And you can imagine all sorts of things I can put in there, can give you some angles here and find out other angles and things like that. Okay, so it comes up an awful lot, so please be aware of it. Other type of triangles that come up a lot in a circle, just use this one here, is if I put a radius in here, then do another radius, and I join the 2 lines up to form a triangle, then the fact that you've got a radius that side, a radius that side, then you have an isosceles triangle, and again you get lots and lots of these. So that angle in here, if we call it x degrees, must be the same as this angle in here, x degrees. So just to show you another one, if I put another radius in here, then we join these up, form another triangle, then these 2 lengths are the same, and we call this angle y, and this angle here must be y as well, isosceles triangle. Another property you have to know, nothing to do with circles as such, just first year work, is that obviously angles in a triangle add up to 180 degrees. I'm just assuming that you already know that. Okay. Other thing we could do is we could take this radius and we could just extend that right up to here. So that's the diameter, and if I join in here, this line here, to form another triangle, and this is the big triangle along here, then that whole angle in here must be 90 degrees from that property there, within that triangle, because we have a big triangle here and we have, this is the hypotenuse, therefore it must be a right angle here because the other 2 lines meet on the circumference. Okay, so that's a combination of these and isosceles triangles. and almost guaranteed in the exam, at some point, your prelim or the National 5 exam, this question always comes up and you have to deal with isosceles triangles and right angle triangles, absolutely, almost guaranteed. Okay, the next one that I'm going to do is we're going to look at a tangent line. So if I draw a line such it just touches the circle, it just touches here, and I draw in a radius from the centre of the circle down to where it just touches the line here. This point here is called a point of contact radius. It's where the radius touches the line and the circle. And it's called a tangent line, so that's a right angle here, and obviously the other side must be a right angle as well, so it's called a tangent line. Now again, I've never known this not to come up. It always comes up. I don't think I've ever saw a past paper that doesn't have a question like this in it, and it always talks about tangent lines. So I could draw another tangent line up here, just touching the circle. There we go. Just touching the circle, and that point there just touches the line, called a tangent line because it just touches the circle. And if I draw in the radius from that point to the centre, that's clearly a radius, and therefore that must be a right angle, and that must be a right angle. And various things we can do here. We can draw another line in to form a triangle, and then we could have various angles put in. You have to find some things. Or we could put another triangle in here from here to here. That means we've got an isosceles triangle. So radius or radius, so this angle in here must be the same as that angle in there. Lots of wee things like that. Okay. It gets to be a bit more complicated, but as long as you know your properties, and the properties are always these properties here, the isosceles triangle or the right angle triangle or the tangent line. I think that's basically it. I don't think there's any other properties that we have to deal with. And the last thing I want to do is questions that not so much to do with angles in a circle, I suppose. It's more to do with the symmetry of the circle. If I draw in a diameter, just for easiness, just draw it straight down, so it halves it in two. If I put in a radius line here, and I put a horizontal line straight across, that's a horizontal line, must be a horizontal line, and join up the other radius here, then this is a very common question to come up as well, because of the symmetry. This line here, the diameter line, and this horizontal line, okay, this is a vertical line here, horizontal line, then that must be 90 degrees. It's a perpendicular bisector of this horizontal line, and it's a right angle here. And these type of questions are usually called the oil tanker type questions. Invariably you've got a question, quite a lot of times it seems to be the oil tanker, but it can be anything. It could be a tunnel, it could be a table, lots of different things. I think one year it was a snowman or something. These type of things, Pythagoras type questions. When you get things like that, okay? So very, very common to come up as well. So knowing all these properties here, that's you covered in terms of angles in a circle, sort of Pythagoras in a circle. Obviously you could do Pythagoras in this question as well because it's a right angle triangle. You could do Pythagoras in this type of question because you've got a right angle triangle, and there's a right angle in here I suppose as well. But when you're just given angles all the time in here, if you're not given any length, if it's just angles that you're given and you're asked to find an angle, it's invariably these properties up here. If you're asked to find a length, more often than not, it was this type of question when you can do a Pythagoras theorem, and because you've got enough lengths, usually give you the radius, and usually give this value here, or the length of this line, something like that. Okay, and I think just while we're here, just to finish off the whole of the circle, we'll look at arc length and area of a sector. So I'll just draw another circle in here. So this is nothing to do with angles in a circle, really. This is to do with arc length. So there's the centre of the circle, put a radius here, a radius here, then it's obviously the same. Well, another type of question that you get at National 5, again, maybe get this once, maybe get it twice, just depending on the paper. This value here, this is called an arc length, this wee bit here. So if I put a wee point in here, point in here, if I call it AB, then if I want to find the distance here, we call this the arc length. And it's a minor arc because it's the smallest line we've got here. If we want to find the other side, that would be called the major arc because it's a longer length. Other things you can be asked to find is the area in here, area of this sector. It's called a sector. So if I was to find the area in there, then it would be find the area of this sector. And this is the minor sector, other side would be the major sector. But I just want to point out the connection between these things. Well, the angle at the centre, if I just rub this wee bit out and I say that this angle's x degrees, then there's a connection, and quite a basic connection, that helps us to work out the area of a sector or the arc length, anything we want to do there. And the connection is fractions of the whole circle. Okay, so hopefully you'll agree with me if I say to you the angle at the centre here over the whole circle, which is 360, that has the same ratio as, we call this the arc length, AL, but arc length AL, over the circumference of the whole circle. And the whole circle, you should know that from first year, it's pi d. So that ratio is the same as that ratio. And if we want to find the area of the sector in here, AOS, area of sector, well, that area over the whole of the circle, but the whole of the circle, again from first year you should know, is pi r squared. That ratio here is the same as that ratio, same as that ratio. And that's something you need to learn from National 5, to do what we call arc length, or area of a sector questions. Okay, so all in all there, that's everything to do with circle at National 5. Okay, so in the next video we will do examples based on everything that we've just talked about there. Okay, so we'll make up 2 questions at National 5. You get one of the, actually probably 3 questions. It will actually make up 3 questions. These 3 up here, I would say that's one type of question you would get and will get in the exam. This question here, another question, and definitely one of these. You might even get 2 of these. You might get an arc length, you might get an area sector as well. So that could be up to 4 questions at National 5, but definitely 3. So that's the end of this video, just a wee introduction into circles at National 5. The next wee video, I think we'll do some past paper questions on these type here. Maybe do two questions, 2 different types of questions for that, because they're all done the same way. If you can do one of them, you can do them all. Then the video after that, we'll do 2 Pythagoras questions, and then on this I'll do 3 questions, because I'm actually even 4. I might do a basic arc length, basic area of the sector, then finding the angle and maybe finding the radius as I'm working backwards. Okay, that's us.